Okay, I'm going to move a little quicker through this problem because there's a lot that we have to do. The first thing is we have to do kind of that completing the square process, but notice there's only x squared and y squared. There aren't any x or y's to the first power, so this makes it a little easier. So basically, to start out, I can divide by 100. And what that does is that makes this hyperbola equal to 1. You always want the hyperbola equal to 1. So then 25 over 100, if you hit math, enter, enter, it's 1/4. So this would be x squared over 4 minus 4 over 100 would be 1 over 25. So that's y squared over 25. So there's my standard form. It's one positive, one negative. So that's how I knew it was a hyperbola. And then I need to find the center. And again, just like our previous problem, there's no numbers with the x squared or y squared. And so I know my center is at 0, 0. So I'm going to label them on the graph, and you can put them, depending on what your numbers are, you can type them in. Now, the vertices, I like to do the vertices first, and that's what WebAssign is asking us to do. And so we always take, with the hyperbola, the first denominator, the positive denominator. And so I'm going to take that 4, and then I'm going to square root it, and I get 2. Because it's under the x, I'm going to go to the right and left 2. So my vertices then are, I guess maybe I'll put it over here, negative 2, 0, and 2, 0. So you always do the smaller x first, larger next. That's what they're asking you to do. But I mark those vertices in blue. And then when I'm doing these pictures, I'm going to take the second denominator, which is 25, and I'm going to square root it, which is 5. And so on my graph, what I'm going to do is go up 1, 2, 3, 4, 5. You can put a dot there if you want, and then 1, 2, 3, 4. These co-vertices are only used to get that imaginary box and that imaginary x going. So basically what you do is you draw a horizontal line, and you draw a horizontal line, and then you draw a vertical line through the 4 vertices and co-vertices, and you can kind of see where that box is. So what I do though is I draw an imaginary. So I'm going to go up and across and down. And then I can draw through the corners of that box. And I'll explain how we can also get that in just a second. So then if I'm trying to find the foci, well, actually now I can go back. Once I've drawn in the imaginary x, these asymptotes, I can go back to my blue dots, which were my vertices, and draw in my graph by going out toward and following the asymptotes. So by doing this, I know this is side to side. X was being squared, so it's a side to side parabola. And now we can find where to place the focus. So that formula is c squared equals a squared plus b squared. So my c will be the square root. All you have to do is add both denominators together this time. So that's the square root of 29. So a little bit more than 5. So I'd go 1, 2, 3, 4, 5, and a little bit more. And that focus, we're adding that to the x value of the center. So that's just positive root 29 comma 0. 1, 2, 3, 4, 5. And that focus would be negative square root of 29 comma 0. So you can put those two numbers in here depending on what your answers are. Now the last thing they want are these asymptotes. And what I was talking about earlier is when I did this box, this imaginary box inside there, I used my vertices and what we'd call co-vertices to draw that imaginary box. But you can also calculate the slope. So the slope in this problem, remember that slope is always y over x, y to the sky. So take what's under y, which is 25. We took the square root, and I got 5. And then you take what's under the x, which is a 4, and we square root that, and we got the 2. So these two numbers, right? Just take the one that's under y, put it on top, and then you do plus or minus. So what I could have done, because it's 5 over 2, I could have gone up 1, 2, 3, 4, 5, 1, 2 to put my dot, up 5, 1, 2 to put my dot, down 1, 2, 3, 4, 5, sideways 2 to put my dot, sideways 2. So if you don't like making the imaginary box, find the slope first, and then from the center, go up and sideways those numbers. So now, if I'm actually finding the equations of the asymptotes, that's what they're asking for here, what you're going to do is go and do the y equals mx plus b form. And so the first one is y equals 5 halves x plus b, and the second one would be y equals negative 5 halves x plus b. So I put my slope in. Now, when you look at this picture, where do those two asymptotes cross the x-axis? Well, they cross right there at the origin, the center. So that is your intercept actually in both cases. So all you have to type in is y equals 5 halves x and y equals negative 5 halves x for this problem.